This is section 4.4, part A, graphing sine and cosine functions. So when you deal with the properties of the sine function, the domain of your function is going to go all the way to the left and all the way to the right. So it's going to go from negative infinity to positive infinity. The range, as long as there's no type of transformation, will go from -1 to +1. The y-intercept will always start at 0. The x-intercepts are going to happen every n pi, as long as there's no type of transformation. It'll be continuous the whole way across. When we are dealing with the cosine, again, it's going to go all the way from left to right, so the domain is going to be from negative infinity to positive infinity. As long as there's no type of transformation, it's going to go from -1 to +1 for the range. On the cosine, instead of starting at the middle, starting at 0, it's actually going to start at the high point for that function, so the y-intercept will be 1. And the x-intercepts, as long as there's no transformation, will be every pi over 2. The portion of each graph from 0 to 2 pi represents one period or cycle of the function, as long as there is no type of transformation. Notice that the cosine graph has just a horizontal translation of the sine graph. So if we look, the sine graph and the cosine graph look exactly the same. The difference is, for the sine graph, you are going to start at 0, 0, and then you go to a high point, midpoint, low point, midpoint. Cosine, they're just picking it up and they're shifting it to the left. So instead of starting at 0, 0, you're going to start at 0, 1 as your high point. Then you go to midpoint, low point, midpoint, high point. But the graphs look exactly the same, just cosine has been shifted over. So any transformation of the sine function is called a sinusoid. Now the general form of the sinusoidal functions, sine and cosine, are going to be y is equal to a times the sine of bx plus c plus d, and y is equal to a times cosine of bx plus c plus d, where a, b, c, and d are constants, and neither a nor b can be 0. Now, if we look at this graph, you can see that the constant function, a is equal to, for a, where y is equal to a times sine of x, expands vertically if that value of a is greater than 1, and it's going to be compressed vertically if a is between 0 and 1. So for the red one, it is stretching up, it's expanding vertically because we have 2 times the sine. So instead of going up to 1, it would go up to 2. And when we have y is equal to 0.5 sine of x, 0.5 is between 0 and 1, it's less than 1. So it's going to be compressed vertically. And so instead of going up to an amplitude of 1, it'll only go up to 1/2. So that value in front of your sine or cosine, that a value, is telling you about your amplitude. And your amplitude just tells you how high up and down your entire function will go. Now the amplitude is half the distance from the maximum value to the minimum value. So this line we call here is the midline. So the distance from your midline to the top is your amplitude, and the distance from the midline to the bottom point is also your amplitude. You will determine this point by whatever value is in front of sine. So if there's no number out there, that means our amplitude is 1, and that just means the highest point will be 1, and the lowest point will be 1 away from that midline. So we need to describe how the graphs are related. Then we need to find the amplitude of g of x, sketch 2 periods of both of the functions. So because this function is 1/4 sine of x, we know it is going to be compressed vertically by a factor of 1/4. Now we need to graph the sine function and the cosine function. Now the sine function and the 1/4 sine function. The sine function itself starts at 0, 0. Let's let our amplitude of 1 be here. Let this be 1/2. This will be -1/2 and -1. Now for the sine function, as long as there's no type of transformation, it is going to change what it does every pi over 2. So the first pi over 2, we will get our high point. Pi over 2 more, we're back at our middle. Another pi over 2, we are at our low. Another pi over 2, we're back at the middle. So since we're at the middle, if we go pi over 2 to the left, we should be at a low point. Pi over 2 more to the left, we're back to the middle. Pi over 2 more, we're at the high. And over pi over 2 more, we are back at the middle. Now once you have those points, you just draw in your curve. And that one is just the f of x function. Now because g of x has that 1/4 in front of it, we know that its amplitude, or its a, is only 1/4. So instead of going up to 1, it will only go up to 1/4. So we're still going to start at the same point. We're still going to change every pi over 2, but at pi over 2 we go up to our high point. But in this case, instead of going up to 1, we're only going to go up to 1/4. Then the next pi over 2, we're back at the middle. Low, middle. So since we started in the middle, we're going to go low, middle, high, middle. So our function of 1/4 sine of x should look like this. So first we described how they are related. They are related because g of x is compressed vertically by a factor of 1/4. We found the amplitude is 1/4, and then we sketched both functions. Now if your a value is less than 0, so if there's a negative in front of your a, that just tells you are going to reflect the function across the x-axis. So instead of going high first, you would go low first. So we're going to describe how the graphs are related, then we're going to find the amplitude and sketch both functions. Now because we have this negative sign out front, we do know it is going to be reflected across the x-axis. And because we have a 3 in front of the cosine, we know it's going to be expanded vertically by 3. So first we're going to start by labeling. So let's do 1, 2, 3, -1, -2, -3. Now we do know that the amplitude for the regular cosine function is just 1, but the amplitude in the g of x in this case will be 3. Now when you go to just graph the cosine function, instead of starting at 0, 0, it's always going to start at its highest point. So since our amplitude is 1, it'll start at 0, 1. It is still going to change every pi over 2 for your interval. So after the first pi over 2, we are now at the middle, or the midline. Then the next pi over 2, we're at our low point. Then we're at our midpoint, and then we're at our high point. So since we're at our high point, we'll go to the midpoint, low point, midpoint, high point, and we will graph that function. So that's just your f of x function. Now for g of x, not only are we changing the amplitude to 3, so the high points and low points will go to 3 and -3, but we've also reflected it across the x-axis. So instead of starting at the high point, we are now going to start at the low point. We'll still change every pi over 2, but this time we will have an amplitude of 3 instead of 1. So since we started at the low point here, we're back at the middle, high, middle, low. So our function for g of x is the one in the purple. Now the period of a sinusoidal function is the distance between any two set of repeating points. So since we have like a high point here and a high point here, the distance between those two high points is one period. So how long does it take to get from a high point to a high point, or from a low point to a low point? To find that period, you're going to do 2 pi over the absolute value of b. And remember, b is the value right in front of your x. Now, to make your graphing easier, once you know the period of your function, to figure out the interval in which you need to change things, your interval is just period over 4. Because if we have a graph, if I'm going high, low, back to the middle, so we started the middle here, get back to this middle here, we've done 1 period. We've done 1, 2, 3, 4 changes. So the interval in which we do those changes will be 1/4 the length of the period. So we need to describe how the graphs are related, and then we need to find the amplitude of g of x. Sketch 2 periods of both functions. So at least 2 periods of both functions. Now, we can rewrite this as the cosine of 1/2 x. Now, because the 1/2 is attached to the x and not the entire function, we do know this is going to be a horizontal dilation instead of a vertical dilation. And we know that it is going to be expanded horizontally. Okay, it's going to be expanded horizontally by a factor of 2, since this is 1/2. Since we're expanding it, we're doing the opposite. And the reciprocal of 1/2 is 2. Now we need to find the amplitude and the period. Remember, the amplitude is just whatever value is right in front of the cosine. So our amplitude will be 1. Our b value is whatever's right in front of the x, which in this case is 1/2. So to find your period, you are going to do 2 pi over the absolute value of b. In this case, that's going to be 2 pi over 1/2, which we can write as 2 pi over 1 times. When you divide by a fraction, you flip the fraction and you multiply. So that'll be our period is 4 pi. Now to find the interval to see where it's going to change, you're just going to take that period and you're going to divide it by 4. So 4 pi divided by 4 tells me our graph is going to change every pi for the purple graph. But for just the graph of cosine itself, remember we have, let's call this 1/2, 1, negative 1/2, negative 1 down there. Cosine itself is going to start at a high point. We know the amplitude of that original one is just 1, so it goes up to a height of 1. And we do know that regular cosine, the interval is that it's going to change every pi over 2. So pi over 2, we're here. Then we're low. Next pi over 2, we're middle. And the next pi over 2, we are high. So since we were high, now we're middle, low, middle, high. And this is the graph of just f of x. Now, to graph g of x, we are still going to start at the same point. It's still cosine, we're still starting at a high point. But instead of changing every pi over 2, our interval now is every pi, because our period is 4 pi. So instead of every pi over 2, we won't hit our middle until pi units later. And then another pi units later after that will be our low point. So since we were at high, pi, negative pi to the left, and then another pi would take us here. So as you can see, all of these points are moving out twice as far as they were before. So this point was at pi over 2. This point is now at pi units farther to the right. So it is expanded because this is 1/2. We do the opposite because it's horizontal. So we are expanding it horizontally by that factor of 2. We're moving them 2 points out, or 2 times out. So if this is at pi originally, now it's at 2 pi instead. So remember that purple one is your g of x.